Welcome to the labyrinth of the mind, where we embark on a journey through perhaps the most beguiling mystery known to humanity, consciousness itself. I'm Professor, and today we'll venture into the unfathomable depths of what it means to be aware, to experience, to be. Consciousness, that ineffable quality that transforms mere existence into experience. The enigma that transforms neural firing into the rich tapestry of your subjective world. What sorcery transforms mere matter into meaning? What alchemy transmutes electrical signals into the experience of a sunset's glow or the melancholy of a cello's song? The question of consciousness has haunted the halls of philosophy for millennia, yet in recent decades, it has infiltrated the laboratories of science. And there it stands defiant, inscrutable, challenging our most sophisticated tools and theories. At its core lies what philosopher David Chalmers hauntingly termed the hard problem, not merely how the brain processes information, but why and how any physical process, no matter how complex, should give rise to subjective experience at all. As Chalmers puts it, why should physical processing give rise to a rich inner life? It seems objectively unreasonable that it should, and yet it does. Consider what we call the easy problems, though they are anything but easy in practice. How does the brain discriminate stimuli? How does it integrate information? How does it report on mental states? These are questions of function and mechanism. Given enough time and technology, they appear solvable in principle, but lurking behind them is the specter of experience itself, the redness of red, the sharpness of pain, the ethereal quality of a memory. These qualia, these subjective experiences, seem to exist in a realm beyond mere function. A computer might process visual data perfectly, but does it see as you and I see? The philosopher Thomas Nagel captured this conundrum perfectly in his famous paper, What is it like to be a bat? We can study bat neurophysiology exhaustively, map every neural pathway involved in echolocation, yet we remain forever barred from experiencing what it is like to navigate the world through sound reflections. That intrinsic, subjective character of experience, the what it is likeness, stubbornly resists objective analysis. This is not merely a gap in our knowledge, it appears to be a chasm between two fundamentally different domains, the objective physical world and the subjective realm of experience. Yet brilliant minds have not shied away from this abyss. They have constructed bridges of theory in attempts to span it. Let us explore some of the most compelling. The global workspace theory, pioneered by Bernard Bars, envisions consciousness as a kind of neurological spotlight. Imagine the brain as a vast theater where countless unconscious processes unfold in parallel darkness. Consciousness, in this view, is what happens when certain neural coalitions gain access to a global workspace, suddenly illuminated on the main stage, broadcast throughout the brain, available for verbal report and rational control. This theory elegantly explains many features of conscious experience, its limited capacity, its selective nature, how it enables integration across specialized brain modules. But critics wonder, does it truly solve the hard problem, or merely describe the neural correlates that accompany consciousness? Giulio Tononi's integrated information theory takes a more radical approach. It suggests consciousness is identical to a certain kind of information integration in complex systems. The theory introduces phi, a measure of integrated information that, according to Tononi, directly corresponds to consciousness itself. The implications are profound and unsettling. If consciousness is integrated information, then it exists on a spectrum. A human brain generates rich consciousness because it integrates vast amounts of information in complex ways. But simpler systems, animals, perhaps even sophisticated machines, would possess simpler forms of consciousness proportional to their information integration. Higher-order theories offer another perspective, suggesting that consciousness emerges from the brain's ability to represent its own representations. It's not enough to see, you must also, in some sense, be aware that you are seeing. Consciousness arises when the mind turns its gaze upon itself. Then there are the quantum theories, most famously proposed by Roger Penrose and Stuart Hameroff. Perhaps consciousness emerges not from classical neural computation, but from quantum processes in cellular microtubules. In this view, consciousness might be linked to the most fundamental aspects of physical reality, to the mysterious quantum realm where possibility collapses into actuality. These theorists ask, could the strange properties of quantum mechanics, superposition, entanglement, non-locality, hold the key to the equally strange properties of consciousness? Biological theories focus on identifying the neural correlates of consciousness, the specific brain patterns and processes that coincide with conscious experience. Researchers like Christoph Koch have made remarkable progress mapping these correlates, identifying regions like the claustrum that may serve as critical hubs in the conscious brain. Yet a nagging question remains. Even if we perfectly mapped every neural correlate of consciousness, would we have explained why these particular patterns give rise to subjective experience? Or would we merely have described the physical conditions under which the miracle of consciousness somehow occurs? Each theory illuminates a facet of the enigma. Each offers valuable insights. But like the blind men examining different parts of an elephant, they may all be touching different aspects of a reality that transcends any single description. Perhaps consciousness is not one thing but many, a constellation of related phenomena with different properties and different explanations. Perhaps our very conceptual frameworks are insufficient for the task. Perhaps we need not just new answers, but new questions. The enigma of consciousness has profound philosophical implications. It forces us to reconsider the nature of reality itself. For dualists like Descartes, consciousness reveals a fundamental divide in nature, between matter and mind, physical and mental. In this view, consciousness cannot be reduced to physical processes because it belongs to a different category of existence altogether. Materialists counter that consciousness, however mysterious it seems, must ultimately be explicable in physical terms. There is only one kind of stuff in the universe. The physical and consciousness must somehow emerge from it, even if we don't yet understand how. Panpsychists offer another possibility, that consciousness might be a fundamental feature of reality, present in some form throughout the physical world. In this view, the hard problem arises because we're trying to derive consciousness from non-conscious components, an impossible alchemy. Instead, consciousness may be elemental, woven into the very fabric of existence. The Mysterians, led by philosophers like Colin Maginn, take perhaps the most humbling position, that human minds may be constitutionally incapable of solving the hard problem. Just as a dog cannot grasp calculus, our brains, products of evolution optimized for survival, not metaphysical insight, may lack the cognitive architecture needed to bridge the explanatory gap between brain and mind. Illusionists take a different tack. Perhaps the hard problem is itself an illusion, not a genuine metaphysical puzzle, but a cognitive confusion. Perhaps consciousness only seems non-physical, non-functional, because we're viewing it through a distorted lens. Perhaps qualia, the what it is likeness, are not features of reality, but artifacts of how brains model their own operations. As Daniel Dennett provocatively suggests, perhaps consciousness is more like a user illusion, a simplified interface our brains construct, not unlike how a computer presents a desktop metaphor rather than revealing its true complexity of semiconductors and binary code. These philosophical positions are not merely abstract exercises. They shape how we understand ourselves, how we conceptualize our place in nature, and increasingly, how we approach the development of technology. As we create ever more sophisticated artificial intelligences, questions of machine consciousness become less theoretical and more urgent. Could a sufficiently complex AI system become conscious? How would we know? What moral obligations would this entail? Some theorists, applying frameworks like integrated information theory, suggest that certain AI architectures might indeed generate forms of consciousness. Others maintain that digital systems, no matter how complex, lack some crucial ingredient for consciousness. Perhaps the biological substrate, perhaps the embodied nature of human experience, perhaps something else entirely. The stakes of this question are immense. If machines could become conscious, it would force a radical rethinking of how we develop and deploy AI technologies. It would raise profound ethical questions about the rights and moral status of artificial beings. And what if we could somehow digitize human consciousness itself? The transhumanist dream of mind, uploading, transferring a human mind to a digital substrate, hinges on our understanding of what consciousness actually is. Is it a pattern that could be preserved in silicon? Or is there something irreducibly biological, irreducibly human, about our form of awareness? These questions blur the boundaries between science fiction and serious philosophy, between technological speculation and genuine ethical dilemmas that we may face within our lifetimes. The scientific study of consciousness also has profound implications for medicine and mental health. Better understanding the neural underpinnings of awareness could revolutionize our approach to disorders of consciousness, from coma and persistent vegetative states to psychiatric conditions. It might even transform our understanding of ordinary consciousness, revealing how our sense of self, our perception of reality, and our subjective experience are constructed moment by moment in the intricate dance of the living brain. Recent breakthroughs in neuroscience offer tantalizing glimpses into this construction. We now know that what we experience as a seamless, unified consciousness is in fact a masterful synthesis, the brain binding together disparate processes into a coherent whole. Studies of phenomena like blindsight, where people can respond to visual stimuli they cannot consciously see, or split-brain patients, whose left and right hemispheres can experience different consciousnesses, reveal how fragile and constructed our unified sense of awareness truly is. As we conclude our exploration, we find ourselves standing before a mystery that seems both more accessible and more profound than ever before. New technologies allow us to probe the neural correlates of consciousness with unprecedented precision. New theories offer conceptual frameworks that might bridge the explanatory gap. Yet the core enigma remains that ineffable transformation of matter into mind, of computation into comprehension, of brain into being. In the face of this mystery, we might do well to balance scientific rigor with philosophical humility, technological ambition with ethical caution. For in the end, consciousness is not merely a scientific puzzle to solve or a technological frontier to conquer. It is the very medium of our existence, the foundation of our humanity, the wellspring from which all meaning and value flow. In seeking to understand consciousness, we seek to understand ourselves not just as biological machines, but as beings who experience, who feel, who know what it is like to be alive in an enchanted universe. The journey continues, and though the destination remains shrouded in mystery, each step brings its own revelation. Thank you for joining me in this exploration of the greatest enigma we know, the enigma that is ourselves.